In section 1.7, we will talk about the chain rule. And the chain rule starts with composition of functions. So first, let's talk about composition of functions. The notation is f, the open circle is read as f composite g of x, which is equal to f of g of x. So basically, a function g of x, it becomes the input for a function f. G of x is the inner function, f is the outer function. Here's a quick example of that. Let's say that f of x is equal to x to the fifth, and let's say that g of x is equal to 3x squared minus 8x plus 4. So if we want to find f of g of x, we will replace g of x with what it equals to. G of x equals to 3x squared minus 8x plus 4. So we can write this as f of 3x squared minus 8x plus 4. So look what happened. We took the g of x function and we made that the input for f. So this becomes the input for the f function. The f of x function is x to the fifth. So this will equal to 3x squared minus 8x plus 4 raised to the fifth power. So this can be written as a composition of two functions, f of x equals x to the fifth, and g of x equals 3x squared minus 8x plus 4. The derivative of f composite g of x is equal to the derivative of f prime times the derivative of g prime. In other words, whenever you have the variable x inside of a parentheses, we have to multiply by the derivative of the expression inside the parentheses. Here's an example of that. Let's say f of x equals to 3x squared minus 8x plus 4 raised to the fifth power. So according to this rule, f prime of x, this will equal to the derivative of this expression to the fifth power. So we're going to bring the 5 to the front, and we will have 5 times 3x squared minus 8x plus 4 to the fourth power. We subtract a degree. But here's where the chain rule comes in. Anytime you differentiate something, anytime you bring the 5 down, and the parentheses has x's in it, then we have to get the derivative of the parentheses as well, which is d dx of 3x squared minus 8x plus 4. Okay, let me repeat that. Because the parentheses has x's, when we bring the 5 down, this becomes 5 times 3x squared minus 8x plus 4 to the fourth power. We also have to take the derivative of the parentheses. This happens whenever there's a variable x inside the parentheses. Okay, that's what this says. But we have to multiply by g prime of x. Now on the side, we can do some work. So we want to find what is the derivative of 3x squared minus 8x plus 4. So the derivative, you bring the 2 to the front, multiply it by the 3, so this is 6x. There's a 1, so this gives you 6x minus 8. So we're going to rewrite this as 5 times 3x squared minus 8x plus 4 raised to the fourth power times 6x minus 8. Okay, always multiply by the derivative of the parentheses. When you differentiate something that has an expression containing x's inside the parentheses. So just to simplify this a little bit further, we can bring the 6x minus 8 to the front. So this will give you 5 times 6x minus 8 times 3x squared minus 8x plus 4 raised to the fourth power. This wasn't necessary, but it just makes it look a little bit nicer. Okay, now if you want to find f prime of 2, we're going to replace each of the x's with 2. So this will give you 5 times 6 times 2 minus 8, that's 6x minus 8, x is 2, times 3 times 2 squared minus 8 times 2 plus 4, and that's going to be raised to the fourth power. Okay, let's keep simplifying this. This gives you 5 times. 6 times 2 is 12. 12 minus 8 is 4. Over here, 2 squared is 4. 4 times 3 is 12. 8 times 2 is 16. So that gives us 12 minus 16 plus 4. That's negative 4 plus 4, which is 0. And 0 to the 4th power is still going to be 0. So 5 times 4 times 0 will just give you 0 as the answer. Next example, we got f of x equals to 6x cubed minus 19 raised to the negative 3rd power. So f prime of x, we bring the negative 3 to the front, so this gives you negative 3 times the quantity 6x cubed minus 19 to the negative 4th power because we subtract 1, but we have to multiply this by the derivative of the parentheses, which is 6x cubed minus 19. We always need the derivative of the parentheses whenever this parentheses contains an expression involving the variable x. Okay, so let's simplify this a little bit. This gives us negative 3 divided by, we can't have a negative exponent, so move it to the denominator. This gives you 6x to the 3rd minus 19 raised to the 4th power. You move it to the denominator, the exponent becomes positive. And then we're going to multiply it by the derivative of this. So 3 times 6 is 18, and this will give you 18x squared. So negative 3 and 18x squared are both on the numerator. So if I simplify this, then f prime of x will give me negative 54 x to the 2nd power divided by 6x cubed minus 19 raised to the 4th power. Okay, that is our derivative. Now we want to find f prime of 1. So we take negative 54 times 1 squared, all of that divided by 6 times 1 to the 3rd minus 19 raised to the 4th power. So 1 squared is 1. 1 times negative 54 is negative 54. Here, 1 cubed is 1. 1 times 1 times 1 is 1. And then 6 times 1 is 6. 6 minus 19 is going to be negative 13. So we need negative 13 raised to the 4th power. So you can do this individually, or you can do it all at once. It's up to you. I'll do it all at once just to show you guys what the numbers will look like. So if we take negative 13 to the 4th power, this will give us a pretty big number, 28,561. That's positive because you have negative, 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 negative multiplied 4 times since it's to the 4th power. This gives us a positive. And if we take negative 54 and divide that by 28,561, we're going to get negative 0.00189, but then we're going to round to just negative 0.0019 to have our four decimals. Okay, next example. We've got f of x equals to the square root of 3x squared plus 7x minus 5. We want to find f prime of x. First of all, we're going to rewrite f of x. We're going to rewrite this as 3x to the 2nd power plus 7x minus 5 raised to the 1/2. Okay, remember the rules for derivatives. Any radical form needs to be written as a rational exponent. Now for f prime of x, the 1/2, this is going to come to the front. So we get 1/2 times 3x squared plus 7x minus 5 raised to the negative 1/2. But anytime this parentheses contains x's, we need to multiply by the derivative of the parentheses, which is d dx of 3x squared plus 7x minus 5. Okay, let's continue simplifying. The negative 1/2 needs to be moved to the denominator because remember, we cannot leave a negative exponent in our final answer. So it's going to go to the denominator. And remember, 1/2 is just going to be square root. So I'm going to say this is 2 times the square root of 3x squared plus 7x minus 5. And then we're going to multiply this by the derivative of 3x squared plus 7x minus 5. So the 2 multiplies to the 3. This becomes 6x. And then we got the plus 7 because 1 times 7 is 7. Okay, so we're going to get 6x plus 7 on the numerator, that's 1 times 6x plus 7. The denominator is going to contain 2 times the square root of 3x squared plus 7x minus 5. And that is our derivative. Finally, we want to find f prime of 4. So for f prime of 4, we're going to have 6 times 4 plus 7 divided by 2 times the square root of 3 times 4 to the second power plus 7 times 4 minus 5. If I keep simplifying this, 6 times 4 is 24, plus 7 is 31, divided by 2 times the square root of, let's simplify this a little bit, 4 squared is 16, 16 times 3 is 48, 7 times 4 is 28, and then we have minus 5. So if we add 48 plus 28 minus 5 gives us 71. We have 3 divided by 2 times the square root of 71, or 31 rather. We can convert this into a decimal. So if we take 2 and we multiply that by the square root of 71, this will give us 16.8523. And if we take 31 divided by 16.8523, we will get 1.8395 as the answer. Okay. The next examples we will cover in the next video.